Hey everyone, welcome back to the channel. In this video, we'll talk about how to create a polyfill for Array.map. So let's get right into it. Now we have to implement a function called myMap that behaves like Array.map, right? So again, implementing this function would give you a sense that how map works under the hood, and it is also important from interview point as well, right? So again, just like we do in our previous questions, we will note down the requirements, we'll try to understand the problem, and then we will go to the solution, because that's a very good way to code at the end rather than missing out on the edge cases and then debugging the whole code in front of the interviewer. So if you see that we have basic example usage here. So we have an array, and this array is running my map. So we have a callback, and it is taking a num, it is saying num into 2, and you can see the expected output is 2, 4, 6, 8, 10, and this is nothing but a transformed array that is being written. Okay, the other example here is that we have words or array of strings. So it is doing uppercase to each of the word, and this is the output. So in order to do that, let us write down our requirements, but also if you want to dive more into the map function and its nitty-gritty details, you can go here and you can go to the MTN, read more about it, go to the examples, see how it's being used, go to the description, research more on it, and then find out the edge cases. So it will be a good exercise. So again, if you just read the definition here, the map method of array instances creates a new array populated with the results of calling a provided function on every element in the calling array. Great. So with this, let us write down our requirements. So the very first thing we can do is it returns a new array. So this is important, right? It returns a new array. Also, it takes a callback function. That would be the second requirement. And we can also say that it maintains the original array length, because if you see 1 2 3 4 5 is nothing but 2 4 6 8 10, and the callback is called, you can say, for each element, right? But if you dive more into this, you'll see that okay, it's not about only the element, you can also get the index and the array itself, right? So the callback function basically passes or gets the element, the index, and the whole array. But in most of the examples we don't use that, but this is something that map provides, right? So we will also have to do that. All right, so with this, let's start implementing our polyfill for map. So the very first thing that we can do is we can create a new array. Let's say result, and we can say return. So this result would contain the transformed elements, right? So what we have to do is we have to loop through the array, right? So in this case, array is numbers, and this case is words, and then so on, right? So always remember, guys, how do we get this numbers or this words or this array here, because this is changing, right? In this case the array is numbers, in this case the array is words. So always remember, when you have a method, right, a method is nothing but a function inside an object. So whenever you call a method or a function like this, the this keyword will, that is a special keyword in JavaScript, will point to whatever the left side of the dot is. So left side of the dot is words, here the left side of the dot is numbers. Okay, and you can just console it out to check only for this case, right? So this is a very important keyword, and it changes its execution, right, depending on the case. For this case, it will represent the array or whatever that is there on the left side of the dot, right? So if I just run, let's say node index.js, you'll see that we get the array, right? That is 1 2 3 4 5, and then so on. In this case, it is hello world. Great. So now what we can do is we can say that for Let's loop through it. Let I equals to 0 and I is less than this dot length. We can say I plus plus. Now for every element, right, we need to process the callback. So we can say callback and we can pass the element. What is the element? This at index I, right? And the index, that is I itself. And the third thing is array, that is the this itself, right? And then we can finally say result dot push, and this is fine. We push the result and we return the result. So let us try to run this particular polyfill, and you can see that we have 6 test cases pass and 2 are failed. So almost this is our working polyfill for map, right? That's great. This you can cover in the interviews. It is fine. You'll get the marks. You'll qualify. But if you pass these 2 failed cases as well, these are very, very specific cases, right? For example, if you see here something related to the object and something related to the sparse indexes. Now this you will find only if you go through the documentation in detail, because here you will see that we have something called as thisArg, we have something here that is sparse arrays. So you have to research, and if you cover this in front of the interviewers, right, they will be really, really impressed. So what we can do here is, let us try to understand what happens or what is the output when we run these 2 my maps. So let me run node.index, and you can see here that the first thing we are getting is NaN, right? This is not expected. We want 3, 6, 9, 12, 15. And for the second case, that is sparse map, right? Here it is giving 2 NaN 6, NaN and 10. But we want here 2, then empty, because in the original array it is empty, then 6, then it is empty here as well. So we have to retain the empty elements as well. Now these 2 are very, very important edge cases. Now how do we solve this? So let us go with the first one. So in the first one, you can see we have this context object, and the context object we are passing it as the second argument, right? So the context object, we are in the callback, we are saying this dot multiplier. Now this is not pointing to the context. This keyword is pointing to the array, right? This keyword is pointing to the array. So how we can link the callback, that is inside the callback, that is this dot multiplier, to the context object? So in order to change the behavior of this, we have a couple of methods on the function, right? So we can use call, apply, bind, and call and apply would make more sense here. So what we can do is we can say call back dot call, and the first argument we can pass as the object itself. So now this keyword will be pointing to the object that we are passing here, that is nothing but the context, and then this dot multiplier would work as it is. And then the rest of the arguments are the rest arguments that you can pass, that you want to pass in the function, right? So this is how we bind the particular object with this callback function. So now if I try to run this particular file, you can see that 7 test cases passed and we got the output, that is 3, 6, 9, 12 and 15. That's great. The last case that we are failing is this sparse issue, right? So what we want to do is we want to be able to maintain these empty spaces. So first thing we can do is we can create a result, and we can create with the same length as this. So we can say new array, and this will also include the empty spaces, right? So this will create a new array and it will preserve all the empty spaces that is there in the original array, right? Now we cannot do push here, because if something is empty, right, you do not have to push, you have to preserve that position. How do you do that? So what we can do is we can say if, and we can say if I in this, only then we do something like result at index I, and we pass on the result of the callback. So we'll not use push here, we will do it like this. And what it will do, in case of empty, it will leave it as it is, but only when we have the index, right? Only when we have the value, it will preserve that. So what we can do now is we can try to run this particular file, and you can see that all the test cases have passed, right? And these are the very important edge cases that we have covered here. And ideally we should understand all the requirements, right, and then only code, and that is why we can cover all the edge cases at this particular point. Also, when you are trying to find out the edge cases, please note it down in the requirements, otherwise we have a tendency to forget, right? So that's all for this video, guys. Please let me know if there is any feedback, and if that helps, please also give it a like and subscribe to my channel.